Hello everyone,
Hey, hi Bhargav.
Hello.
Hi.
Hi everyone.
myself Bhargav. We are from Team 3 Innovators and our project name is Calorimet Application. So this is our agenda. So team members, roles and responsibilities, improvements from professor feedback, project description, team working agreement, personas, MVP, technologies, algorithms, diagrams, product backlog, Sprint-2 backlog, metrics, retrospective, Sprint-3, project demo Sprint-2, GitHub link, live application demo. So these are we are going to presenting in this PowerPoints. So this is our team members. Ranjitha will
Hello.
introduce.
Hello, hi, everyone. My name is Ranjitha Durgasai. I'm a front-end developer and I'm a team leader as well.
Yeah, hi everyone. I'm Nikitha Reddy, front-end developer.
Hi everyone, this is Harshitha Koapati Murali and I'm a backend developer.
Hi everyone, myself Bhargav, I am a backend developer.
Hi everybody, I'm SaiKumar. I'm a machine learning engineer and a scrum master.
Next slide, please.
Yeah, this is the improvements. So we are fixing the storage and this completed. So this is the project description page. So our project name is Calorimet. We are from Innovators. So our description here, what's that for health conscious users who want to easily track their food intake and manage their diet. So with this, we are using our Calorimet application is a smart AI powered solution that automatically identify food from photos and calculate nutrition and offer specialized meal suggestion. So the unlike traditional Calorimet application requires manual data entry, but here we are using AI, so it's automatically calculates the nutrition and offers the personalized meal suggestions. Our application provides a fast, hassle-free way to track calories and nutrients and saving time and improving accuracy. So these are the outcomes we are getting here is time saving, improved accuracy, health goal support, convenience and consistency. Time saving is nothing but before I explained you. We will reduce the time while entering the manual. So we are using the AI here. So it will be save your time because we are using the photo analysis without manual data entry. Improved accuracy. AI provides precise estimates for calories and nutrients and reduce the guesswork. So we are guessing how much nutrients do we have and calculating ourselves. But here we use the AI and we estimate the calories and nutrients automatically. Health goal support. So we provide the personalized diet plan and help users stay on the track with their weight loss, muscle gain, and overall wellness goals. Convenience here. Barcode scanning for food package and makes nutrition tracking fast and effortless. Consistency. Easily we can track. It's a user-friendly engagement and encouraging long-time healthy habits. So from here to Nikita will gonna take care about the team agreement.
Yes, thanks, Bhargav. As a team members, we all should work as a team, and these are the very key points we should work on. First one is communication. As a team, it is very crucial that we are on the same page and assign the goals very clearly. And second one is decision making. As a team, we should work on decision making. Is very important that we all work together and prioritize the right tasks and make progress towards sprint goals. And next one is team meetings and collaboration. As all team, we should agree on key points and schedule regular meetings twice a week at certain time via Zoom or something. And our main agenda is to make all team members work and make submissions on time. Next one is deliverables. Each sprint should lead to producing the outcomes like presentation updates to technical papers and make sure that all the reviews and test cases of our work will be submitting it for consideration. Next is roles and responsibilities. Each member in a team should assign equal roles and responsibilities based on their work given in the front end development and back end development and machine learning. Coordinate with teams to seamlessly incorporate various functionalities. And next one is retrospectives. After each sprint is completed, it's very important to have a session to review the successes and areas for improvement, as well as to outline specific steps for the upcoming sprint. Next slide, please. Here we are taken few personas as an example. In this slide, we are given as Sneha as an example, who is a fitness freak. Her age is 28. She works as a marketing specialist, and her goal is to build muscle and maintain a healthy diet. And the challenges she's facing is to log every meal and calculate the proteins and carbs and fats as she's consuming on a daily basis. However, Calorie Mate helps. Emily can take photos of our meals to instantly track nutrients, saving time and keeping her fitness plan on track. Next slide, please. Here we are taking Surya Cook, a busy professional, as an example. His age is 35 and is working as a software engineer. And his goal is to lose weight and adopt healthier eating habits. And his challenge facing is limited time to research on record calorie information due to his demanding work schedule. However, Calorie Mate helps. It helps Surya to take his photo recognition of his meals and making calorie management fit seamlessly into his day. Next slide, please. Here we're taking Kruti Patel as an example, who is a health conscious parent. Her age is 42 and she's working as a teacher. Her goal is to maintain a balanced diet and teach her family healthy eating habits. And the challenges she's going through is nutritional content of home cooked meals. However, Calorie Mate helps. Kruti can easily track home cooked meals using photo recognition and adjust portions to get accurate nutritional insights, helping her meal plans for the entire family. From here, my friends, Sai will take.
Yeah, thank you, Nikita. Here's a quick overview of the core features of our minimum viable product, which is MVP. First, the app can identify food from photos using AI. User just take a picture of their meal, and the app recognize the food items instantly. And secondly, it automatically calculates calories and nutrients like proteins, carbs, and fats using non-nutritional data and portion estimates. Third, users can scan barcodes on packaged food to log them quickly and accurately. And next, we have a daily routine, daily nutrition dashboard, which helps user track their progress and next to stay on the target. Finally, based on the personal health goals like weight loss or muscle gain, the app offers personalized meal suggestions to users, to guide users towards better choices. And next slide, technologies that we used, a modern and scalable tech stack we are using to build this app. For the front end, we used Expo with React Native. So this lets us build once and deploy on both Android and iOS, ensuring a smooth and consistent mobile experience. User can easily access our app through Android and iOS platforms. So we are using front end Expo as our front end. Next slide, please. And backend, the backend is built with Fast API, MongoDB, and AWS. Here, Fast API handles API requests between the mobile application and the database and the machine learning models also. And coming to MongoDB, MongoDB is used to store user data like meal logs and preferences in the flexible and scalable way. And coming to AWS, AWS powers the cloud infrastructure and provides hosting for APIs, storage, and model inference. And all these are highly reliable and scalable. Coming to next slide, please. Machine learning stack. For our machine learning components, we use PyTorch and Hugging Face. PyTorch, PyTorch was used to build and fine-tune our food recognition models. That's why we are going to use PyTorch because we are deploying AI models for our food recognition and nutrition estimation. And coming to Hugging Face, and this Hugging Face provides us with pre-trained VLM, that means vision language model, and this is significantly improved the accuracy of the food recognition from images and saved us a lot of development time. Next slide, please. And algorithm that we are going to use is Instruct BLIP model. At the heart of our system, this is an advanced AI model, Instruct BLIP, and I'll give an overview like how it works. Like a user is going to click a picture of their meal, then the instruct BLIP model process the image, identifies multiple food items, and returns highly accurate predictions. So once the food items are identified, we run a nutritional estimation algorithm by using instruct BLIP, and which calculates calories, proteins, carbohydrates, and fats based on the standard nutritional database. And the entire process is automated, fast, and designed to be user friendly, making nutrition tracking easy and accessible for everyone. That's why we are going to use all these tech stack for front end, back end, machine learning, and instruct BLIP as our algorithm. Next slide, please. I think Vikrant will continue these UML diagrams.
Yes, thank you, Sai. This is an architecture diagram that we have here. So this diagram illustrates how the Calorimate app process the food input that we give. Firstly, the user either uploads a meal photo or he or she scans a barcode. This goes into the front end, which is the app's interface the user interacts with, which then sends a request to the backend, which is the app's brain. So the backend uses AI service, which is to identify the food from the photos, and the nutrition service, which is to calculate all the nutritional information the food has, and the database, which is to store all your meal logs. And we also have the dashboard service to display all your tracking data. So essentially, this diagram it shows a flow of information from the user, from the app services, and the back to the user in a very structured way. Next one, please. For the context diagram, we have which starts with us, the user. This is where it all starts. So you're the one using the Calorimate app on your phone to track your meals. So the big box in the middle is the Calorimate itself. So think of it as the main coordinator. It's on the app on your phone that takes in all your information and uses other services to help you to manage all your calorie intakes. So if you look at the helpers of the Calorimate app that works with, we have database. This is like the app's memory. This is where all your information like your meal logs, your settings, and etc. are stored. So the app can remember it for the later usage for the user. So the arrow going down to the database here means the app stores data there, and we also have the AI service here. So this is the app smart helper, if we can say. um so that this the main role of this is to recognize the food in your photos, which are in your photos when you upload it into the app. So when you upload a picture of your meal, the Calumet app, it sends it to the AI service to figure out what you're eating. So the arrow going into the service means the app uses it currently when the user wanted to. Then and We also have the nutritional database. This is like the app's nutritional enclave. Like you can say the dictionary, it contains all the information about the calories, protein, carbs, and other nutrients in all the different kind of foods. So the Calorie app, it fetches all the info from the database to tell you all the nutritional content of the meals that you browse for. And we also have the dashboard. In the last, this is how the app shows you all the information in a very clear and very easy to understand way. It's like a personalized report that displays all your calorie intake, nutritional breakdown, and all the progress uh, towards the goals that's happening. And this the Calorie app also it then generates this dashboard for you in simple terms. We can just say that this context diagram shows the Calorie app connects you with different tools and information sources to help you with your tracking on the daily basis. The next slide. For the entity diagram, it illustrates how Calorie app organizes its data. It centers on the three entities we have here: user, which stores information like user ID, name, email, password, and goal. And we have meal entity, which stores information about the meal logs with meal ID, date, meal type. And we have food entity, food item entity, which has all the information about the nutritional data, including all the food ID, food name, calories, proteins, carbs, and all the fat it has. So user can log many meals here, and a meal can contain many food items, with with each food item appearing in multiple meals. So this structure allows the app to manage all the user data. Importantly, it tracks all the meals and also provides all the nutritional details very efficiently on the daily basis. The next diagram, please. So for the sequence diagram, we have like we can say like imagine if you are using a Calendar app to track your lunch by just taking a photo. So the sequence diagram here shows all the simple steps that happen behind the scenes. So firstly, the user he takes a picture of the food and upload the meal photo to the front end, which is the app on your phone, and then the front end that sends the photo to the back end, which is the app's main brain in the cloud, and then the back end tells the AI service, which is the app's food recognition expert, to analyze the photo that you have just uploaded. Then the AI service looks at the picture and sends back the detected food items to the back end, like so for suppose we can say like apple or chicken. Then the backend then asks the database, which is the app's food information storage system where all the information is stored, to fetch the nutritional data of those specific items that the user has uploaded. Then the database, after fetching the data, it sends back the nutritional data like calories, protein, or etc. to the backend. Finally, when the backend sends the detected food and nutrition information, which is collected from the backend and database back to the front end, and the app shows you what it found when the user requests for it. So it's like a we can say it's like a quick conversation between different parts of the app to identify your food and tell you what the food is about. The next diagram, please. For the stake diagram, we have this activity diagram illustrates the sequence of steps that which are involved in adding a new mail to the Calrimate app using a photo recognition software. So first thing is we upload a photo. The user initiates the process by uploading a photo of their meal. Then the detection. The app's AI content component analyzes the photo to identify the food items and their quantities. Then it reviews. The app displays the detected food items into a user for review and confirmation. So we also have an option called user edit, which is optional. If the user notices any error in the detection, they can actually make the edits to the food items or the quantities before they actually finalize it. So when the user confirms, it enters into the user confirm stage, where it once the user confirms the accuracy of the detected food, the quantities, then the process proceeds. Then once it's confirmed, the meal is confirmed and it is added to the user's a meal log where he can access whenever he wants to access his food items or the previous logs. And we finally have the dashboard updated every time. So the app updates the user dashboard with the new meal, reflecting the latest calories and all the latest nutritional intakes. So overall, this activity, also the state diagram, provides a visual representation of the user workflow in which is involved in adding a new meal to the Calrimate app using a photo recognition. Next diagram. For the class diagram, we have so this is a blueprint of the Calrimate app structure, showing all its main parts and how they interact. So we have the user who represents app users. It stores user data like user ID, name, email, password, and their goal, which is, for example, we can say losing weight. So users can also do things like log meal, which is like record a meal, and also update the goal. Suppose we can say change the goal. So this all comes under the user one, and we also have the meal entity, which represents a logged meal. It stores all the meal details like meal ID, meal date, and all the meal types for suppose we can say breakfast or lunch. And we also have the add food item action, which means the food can be added into the meal. We have food item which represents food. It stores multiple nutritional info of the food like food ID, name, calories, protein, and carbs and fats. Then we have nutritional calculator, which is a tool that calculates all the nutritional it sums up the all the nutritional quantities of the food like calories or etc of a meal. So it has the calorie nutrition action too. The arrows show relationships here. The logs means a user records many meals. The contains means a meal is made up of many food items. The users means a meal uses the nutritional calculator to get its total nutritional content. Um, for to sum up, we can say it's a design plan showing the users their meals, the food in those meals, and how the app calculates all the nutrition of the food. So that's it. Can we go to the next slide, please?
Yep.
Yeah, my teammate will continue from here.
Uh, so this is our product log. Um And we have a user stories of 5. And our user stories are starting from to creating an account and login information. So the data will be saved. So whatever user information will be there. So it's gonna be stored over there. And their acceptance criteria is user can sign up and log in and error shown for the wrong credentials and logout also works. And we have a feature about authentication, and we have story points 3, and this is sprint 1 we already did. And the next user story is that we want to the user want if the user wants to upload a meal photo, or they want to take an image from the camera, so they can manually enter any food details. So they can upload any image or take a photo, and they will get the input food items. And even if the error shows, there will be no food items will be added. This is acceptance criteria. And the feature is that photo upload. And we have a story points of 5, and these all are the sprint 1 only. So, and next story is that we have to if any user or anyone want to, he or she want to enter a manual food item, so that they can track their meals every day, whatever they want to do, like breakfast, lunch, dinner. So users can enter food items manually, and they can input the portion size as well. And data is going to be saved to the meal log after every confirmation of the meal entry. And this is called, if this feature is called food entry, and we have story points of 3. And the next story is that they if he or she want to edit the food items, then the meal log will be accurate. And so then they can identify the food name and portion size, and they can change automatically the meal logs also will be changed. And this feature is called manual food editing. And we have a story points of here 3. So the next user story is that we have a daily dashboard, so that they can track their calories and nutritions. And dashboard shows the calories consumed and remaining budget. And the macro breakdown also will be shown in every meal entry. So this feature is called dashboard, and we have a story points of 3. So the next slide, please. And we have here the technical stories of every user story, and we have acceptance criteria as well, and we have a features here, and we have the story points. As you can see, this is also sprint 1. And for the first technical story is that we have an authentication backend, and every database will be created for the users, and we have a sign up, login, logout, and APIs ready, password securely stored, and every application program language will be stored. And this is called authentication backend, and we have story points of 3 here. And the next technical story is that we have a photo upload UI. So the users can upload their images from the gallery, or they can take the photos by the camera instantly. So this feature is called photo upload, and we have story points for this is 5. And we for every user story, the next technical story for the user story is every food manual entry. The users can enter their food names and portion size easily by manually only by uploading the picture or and the next this feature is called food entry, and story points is 3. The next technical story is that food editing. The users can edit their food items and portion size, as I told you in the user stories. So this is the technical story of the backend, the manual food editing, and we have a story points of 3 here. This is the dashboard UI and backend, and dashboard reads every meal log and calculates the every total and macro breakdown also. This is called dashboard backend and UI. Here the story points of here is 3, and this is the sprint 1. Next slide, please. So here we have the rest of the user stories for the sprint 2, which we did in this sprint. And I'm going to discuss about these user stories and acceptance criteria and features and story points of this sprint 2. So the first user story is that we are going to scan every barcodes to log the packaged food, so that we can log faster. And the barcode scanning works, and if you want to find any product in the database, the meal logs will be added to the backend only. So the barcode, this feature is called barcode scanning, and here we have a story points of 5. And the next story, I just want to set if user or he or she they want to set any health goal, they can see the calorie target is personalized. Goals can be set and the calories targets are updated, and every goal will be changed later. And the goal, this is the goal settings. And the story points here is two. And then next user, uh, if they want to see the daily macro breakdown, the meals will be balanced. And the dashboard shows the grams and percentages for the every macro down updates and for every meal log. This is called the dashboard. And here where story points is two. And next he or she they want to edit or delete the past meal entries to, so they can fix these mistakes. The past meal listed and edit or delete option will be also working here. And the dashboard recalculates after every change if we delete or if they want to edit. So the last past meal and they want to edit again the past meal, the meal will be recalculated again and again. So this feature is called meal log management. We have a story points of three here. And the next user story is that they want to view every full meal history so that they can review the past eating habits, whatever they have eaten in the past. So the past meals will be listed by the date so they can easily find whatever they have been have the past calories or breakdowns, macro breakdown. This feature is called meal history. And here we have the story points too. Next slide, please. So these are the technical stories of Sprint 2, which we have been done. And again, the same thing, the user stories, acceptance criteria and features. And we have the story points of here as well. And here we have the same for this technical story, the barcode scanning backend, and we are going to focus on the backend and food database. So every food database will be included and packaged food, and the barcode scanning will be works on mobile and directly to your log. You can open the camera and you can open the barcode scan by the code, so that you can open whatever the food will be there, no, that will be updated. And this is called barcode scanner backend. And here we have a story points of 5. And the next one is goal setting feature. The goals will be stored in a user profile, and they can adjust the calorie target in every dashboard, in their dashboards. And this feature is called goal backend. So the next one is macro breakdown logic to the dashboards. So the dashboards is calculates every macro meal of the user, and they updates automatically. We don't have to do it anything. So this is called dashboard logic. And here we have the story points for two. And next user story is that they have to build meal history with the edit or delete option. Here we can edit or delete. In the Sprint 1 we haven't updated, and Sprint 2 we have updated the edit and delete option. So every meal logs will be stored by data, and edit and delete options will be working by the user by API programming language. So the dashboard updates after every changes. And this feature is called meal log backend. And the next the story points for here is 3. And the next technical story is that full meal history page, and meals will be listed by the date so they can find easily. And the clicking opens meal details, and this is called meal history UI. And here we are the story points of 2. Next slide, please. So these are the user stories for the Sprint 3 we are going to do for our app to work more prominently. So these are the user stories and acceptance criteria and features and story points we are gonna do in the future. So I just want to see the calories and nutrition so that user can enter their meal, so that what they are eating. And users can enter the food items manually, and the calories and proteins and carbs, fats are being displayed. And the data is also saved to the every meal log. This feature is called calorie and nutrition display. And here we're gonna have it story points of 5, and this is going to be a Sprint 3 planning. So the next user they want to see a weekly progress report so they can track every long term trends. And they're gonna uh, see the calories of weekly graph shown for them. And we have a macro down calories also will be shown average graph. And this is called progress report, so they can see their report every weekly. So here were the story points of 3. And the next user story we want to set is that we have a setting page to manage their preferences, so that they can customize the app. So user can set the units, metric, and imperial, and the user can change the goal, and changes can be saved immediately also. This is called settings, and story points is two. And we have we are going to have a AI based calorie and nutrition calculation. So user can easily find the food items manually, and the AI calculates every calories, proteins and carbs and fats. So the data will be set to the every meal log, and AI based nutrition calculation. This is called the AI based nutrition calculation, and here with the story points of five. So the next user story is going to be weekly progress backend and UI. The backend calculates every 7 day summary, and UI shows the graph and macro summary as well. And this feature is called progress report. And here with the story points for three. Next slide, please. And the last technical story is that this is the build setting page, backend and UI. And here we have the acceptance criteria, preferences saved per every user changes reflected in the dashboard, and supports units and goals. And this feature is called setting backend and UI. And we are gonna have the story points for two. So overall, this is gonna be sprint 3, technical stories and user stories that we are gonna be on a plan on the sprint 3. So next slide gonna be take care by the Harshita.
Yeah, thank you, Ranjita. From here, I'll take over. Yeah, like here we have listed like a few user stories and technical stories for Sprint 2 backlog. The first user story is like, as a user, I want to scan barcodes to log package foods so that I can log faster. This was the biggest and most technically involved task in this sprint. Our goal was to make food logging quick and effortless. And acceptance criteria was barcode scanning works, and find the product in the database, and it should be added to the meal log. This feature is barcode scanning. And the second user story was, as a user, I want to set my health goal so that my calorie target is personalized. um this now, like, we were introducing a way for users to set personalized health goals, like a daily calorie limit or micro nutrient targets. This acceptance criteria has like, goal can be set, calorie target updates, and goal can be changed later. This feature is goal setting. And story points for this user story is two. And next user story, as a user, I want to see my daily my macro breakdown so that I know like what my meals are balanced or not. This is like basically it is about visibility. User want to know what they're actually eating. The acceptance criteria is dashboard show grams and percentage for macros. Updates. The second one is updates after each meal log. This feature is dashboard. And story point for this user story is three. Sorry, two. And the next user story, as a user, like, I want to edit or delete past meals entries so that I can fix my mistakes. Um, Users may accidentally log the wrong food or forget to update something. The acceptance criteria for this user story is past meals listed, edit or delete works, dashboard recalculates after change. Feature of this user story is meal log management, and story points for this user story is three. And the next user story, the users uh, should be able to view full meal history so that he can view his past eating habits. Here, like, user should be able to scroll through their past meals, click on any date to see full details. Acceptance criteria for this story is all past meals listed by date. Clicking shows full details. This feature is meal history. And story points for this user story is two. Next, next slide. Yeah. Here, like, we have few technical stories. Firstly, like, the first technical story is barcode build a barcode scanning backend and food database. Here, acceptance criteria was like, food database includes all the packaged foods, and barcode scanning works on mobile also, and also the it should be added directly to the log. This feature was barcode scanner backend, and as said, story points for this was 5. The second one is set up goal setting feature. Here, goal should be able to stored in user profile, and goal adjust calorie target in dashboard. This feature is goal backend, and story points for this is 2. Technical story, third one is like add macro breakdown logic to dashboard. Here acceptance criteria is dashboard calculates macros from the meals and updates automatically when the user enters the next meal. And this feature is dashboard logic, and story points for this is 2. The next technical story is build meal history with edit or delete. Here the user should be able to edit or delete. So hence acceptance criteria for this is meal log stored by date. And the second one is edit and delete API works. And the third one will be dashboard updates after changes. This feature is meal log backing, and story points for this is 3. Technical story, the fifth one is build a full meal history page where the user should be able to see the previous meal history. Here acceptance criteria is meal listed by date. Clicking opens meal details. This feature is meal history UI, and story points for this is 2. Next slide. Yeah,
Yeah,
from here my teammate Bhargav will continue.
thank you, Harshitha.
Mm.
So from here, I'm continuing these test cases about. So these are user test cases we test. So here with the first test case, it should be like a barcode scanner functionality. So here we launch the barcode scanner and we open the application, go to the meal log section and tap the barcode icon. And the result, expected result, it should be like, and scanner that activates the camera. And the second test case is like find the product by barcode. Here the steps for execution. Open the scanner, scan a known barcode, wait for the result. And the expected result should be product details are retrieved and displayed. And third test case is add scan product to log. Steps for execution, scan a product, tap add to meal, save the entry. So the expected result is the product is added to the current meal log. And coming to the test case 4, handling invalid barcode. Steps for execution, open the scanner and scan an unknown barcode and wait for the results. Then a message is shown, product not found. So what we can say about if these test cases, all of these test cases for the barcode scanner functionality have passed successfully, confirming that scanner launches correctly, retrieves product details, add products to the meal log, handles invalid barcodes as expected. And this is the test cases, continuation of the test cases. So health goals and macro tracking. So these are the test cases and the description it should be like set health goal. So this is the description and steps for execution is open the user profile and select a health goal. For example, is a weight loss, maintenance and muscle gain. And after that, we can save the changes and expected results. The selected goal is saved to the user profile. So user is nothing but either you or me or someone. And the test cases, the another test case it should be like calorie targets updates based on the goal. The steps for execution here set a health goal, for example, is the weight loss, and navigate to the dashboard and check the displayed calorie target. So here, the calorie target reflects the selected goal and reduce calories for weight loss. And test case, another test case is change health goal later. Steps for execution, we have open the user profile and edit the existing goal. For examples like switch from weight loss to maintenance and save the changes. And the expected result is the updated goal is reflected in the dashboard. For example, calorie target adjust accordingly. It will be updated in the dashboard. And the another test case, viewing the macros breakdown. And here the steps for execution, open the application and navigate to the nutrition or dashboard section. So the expected result here, macros are displayed in grams and percentages. By the conclusion, what we are going to say about this, all test cases are health goal settings passed, confirming that goals are saved calorie targets, updates dynamically, and changes are reflected in the dashboard. So the main thing here, we are changing and updating, and is going to be reflecting to the dashboard. And the macros breakdown are also paused and verified. The users can view detailed the macros information. So this functionality for health goals and macro tracking work as expected. And a few more test cases is for recalculating totals after meal changes. So here you recalculate dashboard values after editing or deleting a meal. Steps for execution: edit or delete an existing meal entry, return to the dashboard and check for the updated calorie or nutrition. And the dashboard recalculates and displays the updated values based on the changes. So coming to that, the another test case is a view past meal entries. So the steps for execution is that open the application, go to the meal history, and view listed meals by date. The expected result is meals listed chronologically. So we pass the test case, and another text case we're gonna is like I discussed about the edit and update the macros and meal entries. So here we can view detailed more information and select a specific meal from the history list, and the expected result is should be like full details of the meal. For example, items, macros are shown. So by this, what can we say is like confirm the dashboard dynamically updates totals when meals are modified. So verified that users can view their complete meal history and access detailed meal information. So by conclusion, what I'm going to saying is a meal tracking and history functionalities operated as intent, ensuring accurate and representation and user accessibility. So these are the test cases before I gonna explain you. So it's a full meal history. I have discussed about that. We are gonna steps is open the application and go to the meal history tab and scroll through the list. Yeah, from here to Harshitha is gonna take care.
Yeah, thank you, Bhargav. Now let's review the completed stories from Sprint 2. This sprint focused on enhancing user convenience, personalization, and data management. Here's what we delivered. The first user story is barcode login. Users can now scan barcodes to log package food, significantly speeding up the logging process. Supported by the technical story 6, where we built the backend and integrated a food database. The second user story is health goal setting. Users can set personalized health goals, ensuring the calorie targets align with their objectives. Supported by technical story 7, involving this involved setting up the goal setting feature in the user profile. And the third user story is a macro breakdown. The dashboard now displays a daily macro breakdown. Uh, Carbs and fats and protein, helping user track meal balance. Supported by technical story 8, this added the logic to calculate display this data. And the second user story, here like the user want to edit and delete past meals entry so that I can fix mistakes. um Here like user is able to like edit or delete his past meal entry so that like if he has done any mistakes previously, he can edit now. And this has like supported by technical story 9. Here like we implemented the meal history with these functionalities. The next technical story is here the user should be able to like view all his meal history so that he can review all the meal details. And this is supported by technical story 10. And this is like built with the page search and filter capabilities. Next slide. Yeah, yes. Team velocity slide highlights development team's performance during sprint 2, where the team successfully completed 28 story points, achieving full completion of all committed tasks. Uh, Team velocity is a crucial agile metric that measures the amount of work completed in a sprint, helping to forecast future sprint capacity. Since all the planned stories were completed successfully, this indicates strong execution and well managed workloads. Achieving all 28 story points within the sprint suggests that the team was functioning efficiently. Next slide. All right, now let's take a quick look at our team's performance over the last two sprints. This bar chart shows the velocity where like in from the sprint 1 versus sprint 2. In sprint 1 we completed 34 story points, which is strong performance and set a solid benchmark. However, in sprint 2 like we have completed 28 story points. Now that, well, that's a decrease. The key takeaway here is that we are maintaining fairly consistent velocity, and this kind of tracking helps us plan future sprints more accurately and allocate our efforts where we need it. Next slide. Yeah, burn down chart is like a visual way to see how quickly you're crossing things off that list. It starts with our total list. At the beginning, the chart shows the total number of things you need to do. It tracks our progress day by day. As we completed tasks, the line on the chart goes down, showing you have less work remaining. Here we can see the red line. We can see the red line. Just give me. Yeah, this shows actual progress of the team. It tracks the total number of story points that were not yet completed at the end of the each day. Notice how it starts 28, indicating that was initial total story points committed for this sprint. The downward trend of this line is what we want to see. It indicates that the team is completing work, reducing the remaining effort over time. You can see some plateau, even some upward movements on certain days. This could indicate that no stories were completed on those days. By the end of this sprint around April 9th, the actual points reaches zero. It means the team successfully completed all the planned work, whereas the brown line is the planned points. The brown line represents ideal and planned rate at which the team should complete the work to finish everything by the end of this sprint. This line acts as a benchmark. It helps us to see if the team is ahead or on track. In this chart, we can observe that the actual progress fluctuates above and below the planned progress. Next slide. Yeah, the completed and or committed ratio reinforces this achievement, showing 100% rate in sprint 1. That is, we committed to 34 story points and completed 34 story points, hence 100%. And in sprint 2, like we had committed to 28 story points and we have completed all 28 story points. These insights indicate a successful sprint and provide a strong foundation for planning. The average completed and committed ratio for both sprint 1 and sprint 2 is 100%. Next slide.
This is
Yeah.
the retrospective that the entire team has agreed on. And first, we can start with what went well. So this section that we highlight all the positive aspects and aspects of the team experience during the last sprint or the period of the sprint. The stickies here, we have multiple stickies that the team agreed on. We can say like daily stand-ups. We have a strong teamwork and cooperation, which is very positive aspect, and we have the teamwork working with full effective and identifying all the issues and resolving them. And we have we did a lot of knowledge sharing. We did on-time task submission. The tasks were completed and submitted on schedule, and we also had the retrospective follow-throughs where the actions have been identified in previous retrospectives which were likely implemented. And we also had the very important thing, we all had a positive mindset, which the team maintained a very much of a positive attitude. And we also would you like to continue here with what can be improved, Sai?
Yeah, in the retrospective, we got a little bit changes. Like we have to change the few things, like what can be improved in the retrospective participation, where each person should be actively participate, and And the next one is streamlined decision making, and we should have an instant decision making skills. And coming to balance between focus and fun, so we are trying to make more fun than focusing on the project, I think so. And coming to the next one is avoid last minute rushing, like we are going to rush in the sprint, like we just left one day, one week, like that. So we are uh, committed to improve that thing. And coming to the next thing, being more open to suggestions. Some of our teammates or everyone in our team had a lot of lot of interesting comments, but they're trying to hide them. So all our teammates are ready, should be open to give suggestions and minimize
Hmm.
mental load with better planning. Like we are trying to take a lot of pressure for these projects. We teammates are trying to reduce the mental load for the better planning and avoid juggling too many tasks. Like we have to stick for each task so that that can be finished primarily. And coming to action items or the things that we are going to improve in the next sprint, like improve documentation, centralized tracking for the project, reviewing sprint goals, and coming to follow up on actions, giving visibility to team. Like we should be transparent to each and everyone, and complete retro action items that we are trying to what we are trying to improve in the next sprint. And coming to clarify priorities, and we should clarify all our priorities for the project, and we should track our progress day by day or weekly during the daily stand-ups. And we should check at least one retrospective action item each week so that the task will be easy to us to complete. Next slide, please.
Yeah, here from here, I'm gonna explain what we can improve in the next sprint 3 planning. Here we have some user stories, acceptance criteria, features, and story points that we're gonna improve in next sprint 3. In first user story, as a user wants to keep a track of the calories and nutrients of every meal so that he or she can know what they are eating. And the acceptance criteria is once user enters food items, all the calories, proteins, carbs, and fats are displayed, and the data is saved to the meal log. It has a feature called calorie and nutrition display, and it has 5 story points. In the next user story, user wants to keep a track of the food items on a weekly progress so that it can help in the long term trends. And the acceptance criteria is weekly calories graph shown and weekly macro average shown. And it is a feature. It has a feature called progress report, and it has 3 story points. In the next user story, as a user, it wants to set a setting space, so manage my preferences so that I can customize the app. And the acceptance criteria is user can set units, user can change goals, and changes saved immediately. It has a feature called settings, and it has 2 story points. In the next technical story, build AI based calorie and nutrition calculation, and the acceptance criteria is user enters food items manually, and then AI calculates calories, proteins, carbs, and fats, and the data is saved to the meal log. And it has a feature called AI based nutrition calculation, and it has 5 story points. And next technical story is uh, build weekly progress backend and UI. And the acceptance criteria is backend calculates 7 day summary, and UI shows graph and macro summary. And it has a feature called progress report, and it has 3 story points. Next slide, please. And next technical story, we build settings page backend and UI. And the acceptance criteria is preferences saved per user, changes reflected in dashboard, and suppose units and goals. And it has a feature called settings backend plus UI, and it has 2 story points. And this we all gonna explain this in the next sprint 3. From here, my friend will take.
Yeah, these are the application screenshots that we are trying to show you. This is the homepage of our application. You can see the log meal, snap meal, and number of calorie count, and that is a goal set by the user. And so, coming to the nutrition overview, there you can see protein, carbs, and fats that user had took 81% of protein, 72% of carbs, 64% of fats, and that is the nutrition overview. And come next one is today's meal. That is the suggestion that our application is going to show to the user, like breakfast oatmeal with banana, which is 320 kilocalories, and lunch like a grilled chicken salad like 450 kilocalories. That is the homepage of our application, and you can see at the top left the date and the hello greeting for the user. And next slide please. And this is an application, this is an example for our application where we are going to click a picture of the food item. So here we are trying to click a picture of the pineapple. So next one, next slide. So we are trying to enter the details of the pineapple first, so that it can be stored in the database, in our meal database, like a food database. And here you can see calories and notes. For notes, you can write anything. Calories, you should mention the calories of that pineapple, and you can save that entry. You can see the save entry button here. Next slide, please. And nutrition goals. A user can, you already know that our application has an option to set nutrition goals for the users. Like your goal is, for example, here user can choose their goal like lose weight, maintain or gain weight, and they can choose any of them. And activity level like low, moderate, and high. And daily targets, they can set their targets for calories, proteins, carbs, and fats, so that our application will show the suggestions of the meals, and user can save their goals there. Next slide. And for example, if user want to add any food item manually without clicking a picture, so that user can easily enter the food item, calories and proteins, that stuff. So the user can save that stuff, so that this thing will be stored in the backend database, food database. Next slide. And this is the API where to retrieve the list of all food items from our server, we use a simple HTTP GET request with a command like curl HTTP colon forward slash localhost 3000 API foods. So that is a host localhost and host number, and where food we are trying to enter the food, so that it will show the food items there. And here the you can see in the curly brackets like the success true, that part confirms that API call was successful. If it is not, it will show like a failure. It will show like false. Success is show like false. And coming to the data, the field contains an array of 20 to 30 food items. Like a user can give their as they can do. Like you can see like fruits like apple, banana, mango, vegetables like broccoli, spinach, protein sources like chicken breast and salmon, and you can see carbs like rice, bread. And this simple API is the foundation for our food, for our application, CaloriMate, and it delivers the full list, the full list of foods. Uh,
Yeah, we can't. We're getting
accurately.
reviewing that. Yeah, exactly.
And okay, probably next slide, I guess.
So here we are getting a specific food, apple. So this is a call command, and it is a local host from the 3000, and API foods. This is the path. So where the HTTP is the security, and we are running the local server here, and it's the data. It should be like a success true. So that means we are our retrieve is true statement. So food, it's gonna apple calories is 52 and units per 100 grams. So food calories or units are the keys. So we are retrieving the data based on this API.
Yeah,
So
sorry guys, due to some network issues, I have cut off. I will explain the page again if you want. Can you go back to the previous slide, please?
yeah, I already
Uh,
explained
but
sorry, that, about that. Yeah, you want to explain?
yeah, yeah, I'll do that again, please.
Sure.
This is an API for the single food item, specific food item. The like to get detailed nutritional information for the specific food item, we are going to use this API called same the get method we are trying to use. So for Apple, we are using this localhost 3000 API foods Apple, so that here you can see the request was successful and the food item is apple and it contains 52 calories per 100 grams. So this API endpoint allows user to quickly check calorie values of individual items, which is essential for precise meal tracking in our application. This is the specialty of our application, so that user can easily track for each item. Next slide, please. And this is the wiki page link. You can go there, you can check our project, you can access our project directly.